this terminal, then you can see this WCA-LU is reading, and this file contains 5 lines, something like this. So you can also do like this. Otherwise, you can also redirect something like this. When you wanted to execute some commands, you can also execute it over here. Okay, then that input will execute the commands. So that way you can input and you can output. So output you can redirect it, input you can redirect it. So how you want to redirect the error example? So let's switch back to the one of the user. I just wanted to change one of the root password, trying to change it over here. So this is an error message here. So how you say that this is an error message? If you put it over and Ravi username or the email address of that user, and then I'm sending this mail as a body to that user. Okay, so here. Okay, so the mail command is not installed over here, so that's why it's not able to succeed that. But you can do this similar way. So this content is goes into the body of that. So I'm not typing any email body over here, but I'm inputting this as the body of that email. So then it's going to send that email saying that so and so message. Okay, so that's the one. Otherwise, if you want to example something like how many lines are there in this file, something like that, you can input this and you can get the same input over here. Something like this. So you're sending this content as a redirection to this terminal, then you can see this WCA-LU is reading, and this file contains 5 lines, something like this. So you can also do like this. Otherwise, you can also redirect something like this. Then you wanted to execute some commands, you can also execute it over here. Okay, then that input will execute the commands. So that way you can input and you can output. So output you can redirect it, input you can redirect it. So how you want to redirect the error example? So let's switch back to the one of the user. I just wanted to
switch
change
user,
one of the
Ravi password. You want to change the password for root.
This is an error message here. So how you say that this is an error message? If you can query this one.
Bismillah. My favorite, lemonade.
The error message is 253. So that's the error message over here. So but I don't want to redirect any of the file content or anything. I just wanted to redirect the error message to somewhere else. So then now we can redirect it here. So you just say to redirect sign and provide something like this. So the error has been not shown over here and it was sent to the error message. So like this, whenever you are doing something, you just wanted to redirect only the error message to the particular log file somewhere else, then you can do to and redirect and sign. So this what happens, the error will be captured into some of the files. You can easily identify that, okay, this is the error message, then you have to do something to resolve that error. So that's the way you can just input, output, and redirect the standard input and output and errors. So in case, so where exactly you can use these methods to input, output, and redirect this input, output, and errors. So here, this would be very helpful when you are typing example. You have a lot of content.
I hate this shit.
In example slash.
That's the difference between admin and engineer. This scripting.
LDR. So this is like you have to be helpful when you are typing example. You have a lot of content. In example slash etc. I would like to see all of this content LDR. So this is like you have to scroll up and down and see all of this information over here, right? Then instead you can just do is that you can just simply redirect to the one of the file example slash etc output something like this. Then what you can do, you can just download that file and put it in a nice format and see that. Or you can also import to the some of the CSV file something like that. You can filter those content based on your requirement, then you can look for the content what you want. So that would be sometime helpful. Sometime I don't want it to enter any commands or any email body something like that, but I want to automatically send the email at particular time to the some users with some standard email body. Then you can also use that way. Sometimes I have scheduled some Chrome tab here. Okay, example say that password root something like this. So that is example I'm saying here. That is the command I would like to do it at every 1 minute from the some other user something like
Cron
this.
tab every
then
1 minute.
I want
Okay.
to capture the errors something somewhere
in error warlog error
messages something like this. So what happens whenever the cron job has been executing, then it has some errors. Then it will redirect to that error messages. Then you can just cat that file every day. Maybe somewhere around when it was failed. Then you can simply go to that warlog error messages and see that okay, the cron job executed with a
cat warlog message.
So that way you can use this standard input, output, and redirections to the in your real-time scenarios. So that would be more useful for the as a big.
Right here. Summary of redirection operations. This is input redirection from a file. Output redirection to a file. Overwrite. Output redirection to a file. Append. To arrow. Ever redirection to a file. To arrow and one combine standard error and standard output. By mastering these direction operators, you can efficiently manage command line inputs and outputs, making your Linux workflows more powerful and flexible.
Beginner and experts or anybody can use this.
We'll show you in real life.
Methods, input, output redirections. Start with basic to enter what are the commands we have, and before running the commands, what are the steps we have to follow, the rules and regulations we have to follow on the Linux command line. Okay, so before you turn over to the next chapter where you are going to, before running the commands, what are the steps we have to follow, the rules and regulations we have to follow on the Linux command line. Okay, so before you turn over to the next chapter where you are going to meet the commands, remember
that's number one.
That
there must be in small case.
All Unix commands. So basically, whenever you are going to enter any commands on all of the Unix-based platforms, like it may be Red Hat Linux, CentOS, Fedora, or Ubuntu, or whatever it is. So, but these are the rules you have to follow in all of the Unix-based platforms. So, all Unix commands must always
L-A is same as LS-LA.
So, it's a case sensitive, means if you have a command in caps or small letters, something like that, you have to enter it to the exact letters. Otherwise, it won't execute. So, if a command has any capital letters, if you enter it in small letters, it won't work. But most of the commands are in small letters, so you have to enter it in small letters only. So, otherwise, the commands won't execute. So, between the command name and the options that may be available with the command, there must always be a space or tab. For example, if you want to execute ls-l is the command. So ls space -l. So that is the command you have to enter it. So here is the command, whereas -l is the option and the two have been separated by the space. So that's what the method here. Whenever you want to execute any options, you have to give the space or tab. This option is usually preceded by a minus sign, so which is called as a hyphen. The option available with the command are often known as switches. So, which are the options which are the switches, like ls hyphen. Command is ls. If you have multiple options or the multiple switches, so you can combine after the hyphen. For example, after the minus sign, like that. So, if you want to enter like the ls hyphen ls, basically instead of okay, so you have to press Ctrl C because you have to remember move command.
So he's gonna show these commands, yeah. We can just get 50 popular most commands in Linux.
All these commands work on Linux, Mac OS, and any other place you have a Unix environment. Colt is an extremely popular instructor, and for good reason. He has a knack for teaching complex topics in a way that beginners can understand.
Hey everyone, my name is Colt Steele, and today we are going to learn a ton about the command line and different Linux commands. I'm a developer, well, honestly, more of a teacher who happens to write code.
It's going to be fun.
I teach in-person web development. I've run boot camps in San Francisco. I now do a lot of online teaching. I have a boot camp I created with Springboard. If you want to learn more, you can find a link in the description. And this is a picture of one of my cats. I actually have to take her to the vet like in 5 minutes, really. Her tail is just drooping down for no reason. I was going to take her sooner, but, you know, I had to pay. He generously allowed, I actually only know him as Flavio. If there's anything else, I want to give a big thanks to Flavio. I think I actually only know him as Flavio. Maybe it's pronounced Copes, but I'm pretty sure it's not. Anyway, he generously allowed me to use his Linux commands handbook. There's a link in the description, of course. Wow. Very detailed and thorough handbook. If you're not familiar with his work, he puts out handbooks and tutorials on all sorts of topics.
Thank you.
So it's just one of many different handbooks. Anyway, he is allowing me to use his handbook along with some of the materials I've created to create this mutant super course on YouTube. So we are going to cover 50, actually I think it's a little more than 50 commands that are useful, obviously to varying degrees. Some of them you'll use every single day as a developer, for example. And then some of them you may never use except in an emergency situation once a year. But I'm going to cover a bunch of them. They're not really in a particular order, especially towards the end of the course. But at the beginning, I ended up deciding that instead of just 50 random commands in any order, I wanted to make something for anybody. So if you're a beginner, you can start at the beginning and we'll go through the basics, navigation, working with the basic commands and options and making folders and files and so on. But then after about this point, things really open up and you can jump around to whatever commands you'd like. And of course, if you're someone who already has some terminal experience, some of these commands are familiar to you, just hop around. Take a look at the description. There are timestamps and just click on whatever command you're not.
I like XRs and alias.
There's probably something here for you. But if you're a beginner, I definitely would recommend starting at the beginning. So aside from these commands, which there's a lot here, and this is a pretty long video, I also cover some concepts that are pretty important. So the very basic things like why even learn this stuff? If you're not a Linux user, you're on a Mac, you're on Windows, why do you need to know Linux commands? Do you need to know them? The answer is probably yes, if you're trying to break into web development, programming, coding, engineering, any sort of techie industry. Then we'll talk about things like Unix and GNU and Linux and Unix-like and true Unix. What is all that? What is a shell? What is bash, Z shell, kernel, terminology stuff? So that's all coming up. Of course, there's timestamps if you want to skip around, if you don't care about that stuff. And then installation. So if you're on a Mac, you don't really have to do anything. If you already have Linux installed, you don't really have to do anything either. And if you're on Windows,
you have to get out VirtualBox.
Hoops. The good news is fewer hoops than we had to jump through a couple months or years ago.
Yeah.
So I'm going to show you how to install something called Windows Subsystem for Linux.
VirtualBox.
Then we'll also talk about concepts like command structure and arguments and options, working with man pages, folder structure of Linux, redirecting standard output, appending standard output, utility expansion, history expansion, path name expansion, curly brace expansion, and permissions. So we're going to handle permissions, a pretty big chunk.
Let's get it.
At the end of this course, is devoted to just these two commands and understanding how to read and
Just
manipulate
these two
permissions
commands.
on Linux. So there's a lot here. There's
5
some
hours
introductory
or
conceptual
50
stuff, terminology,
commands.
installation,
That is
and
absurd.
stuff from the
One
basics.
command, 10
Nothing
minutes?
about the terminal. Never have entered a command in your life.
Is it?
Start at the beginning,
No.
skip around, or
One
if you
command
feel
is like
confident
what?
in this stuff, jump around,
Yeah,
use
yeah.
timestamps. They are there for you. All right, so let's start with a quick discussion around why this matters. Why should you learn these commands? Yes, at times it might seem like you're, doing stuff straight out of a 1980s hacker movie, and
Hacker
they're
movie.
far more advanced and things have improved so much. Why do we still have to use text command?
Hey.
Well, there's a bunch of reasons, including the fact that you can just do a lot more from the terminal. Using these commands you're going to learn, you'll have more control, greater access. You can do things you just cannot do otherwise. There's just no way around that. If you want to start a server, manage different processes, interact with databases, all sorts of things, alter permissions, you need to know terminal commands to do that. Another reason, it's faster. At least once you get past the basic hurdles, you learn the commands, you get used to them, you can do things way faster. We can make 10,000 files in a single line. We can make 10,000 empty files, all with different names. Doing that graphically with my mouse or file new, save would take hours. Now that's just a sort of far-fetched example, but in general, we can do things much faster. The one problem is that when you're learning, it's going to be much slower. I kind of already hinted at this one, but we can actually automate things, we can speed up repetitive processes, we can save ourselves a lot of time. Another reason, it's available everywhere. So if you learn these commands, you'll be able to work on any Linux distribution. You'll be able to then switch over to a Mac if needed and use the commands on a Mac. Now on Windows, yes, it's a little bit different, so it's not technically available everywhere, but these commands you're going to learn are pretty standard across any sort of developer, software engineer career. Which leads me to the next point. It's essentially a requirement. If you want to be a web developer, data scientist, DevOps engineer, sysadmin, security admin, machine learning engineer, AI engineer, whatever, any type of coding-related career, you are probably going to need to use the command line. You will have tools that only exist on the command line that you'll need to be able to use. So for a lot of people, that's the only reason that really matters. You just need it. If you want to get a job, it's just part of the expected skill set. Also, a lot of cloud computing programs or services don't even have a graphical user interface. You just have to do things via a command line. And again, high-paying jobs, lots of careers, lots of roles that you'll need to at least know the basics of working with terminal commands. So the next topic I'd like to quickly discuss is a little bit of context around operating systems and why these commands will work on Linux and on Mac by default, but they're not going to work on a Windows machine, at least not out of the box. So there's quite a lot of complicated history and drama around different operating systems, things being open source versus closed source, and competition, and copying each other. It's quite dramatic, but the general gist that you need to understand is that over the years, since the very early days of computing, well, maybe not the super earliest days, but we're going back to the 70s here. This is a timeline that shows, a very detailed timeline that shows operating systems and how they're connected. Anyway, in the 1970s, there was something called Unix. You can see it here. And just take a look at all of these lines, this whole family of operating systems that it spawned. So there's lots and lots of them. Everything in red here is considered in some way related or indebted to Unix. So that includes things like Linux. So in this course, I'll be using Ubuntu. You can see here, it is a distribution of Linux, but there's many, many others. Things like Android, Chrome OS, but also other more common Linux distributions like Fedora or Red Hat. Anyway, all of this Linux stuff is descended from Unix all the way back here in the 70s. Now we also will see somewhere in here all the different Mac operating systems. Here we are. So Mac OS X, we've got iOS, the Apple TV OS, Audio OS, Watch OS, all these different Apple products, all the Apple operating systems
that's a lot.
also related to Unix. But then our good friend Windows, somewhere down here, it's not even in the same red color, just to show how it is completely different.
That's
it is
a lot.
green. This world
green.
of Windows.
It's
So
green,
Windows, Windows Vista, Windows XP, Windows Mobile, Windows Phone, Xbox OS, all that stuff is over here. It's just kind of on its own. It is not related. It's not a descendant of that original Unix operating system from way back in the 70s. Now the reason this matters is that all of these guys
Linux
in
and
red
Unix
here,
are
they tend
open
to share
source.
the same commands. Unix was this operating system developed in the mid-60s at Bell Labs, really cool time, lots of innovation going on. But what matters to us today, 50 plus years later, is that lots of those innovations, lots of those new ideas and the specific commands, the actual interfaces, the way a file system is structured, all of that carries over today. Yes, it's changed, it's been expanded, but it is present in all of those red descendants of Unix. But unfortunately, for our Windows users, those commands don't exist natively on Windows. Windows has its own set of commands, its own default shell, its own way of doing things. So I'm going to talk about how we can get these Unix commands to work on Windows, but just so you understand why this is a problem in the first place, it just has to do with the history. There are so many of these OSs over the years inspired by and descended from the original Unix OS, including Linux and Mac OS, but not Windows. only Windows over here. All right, so now we have a basic understanding of the fact that of today's operating systems, there's really those two groups. Everything descended from Microsoft, and then kind of everything else that is in some form, some way related to Unix. Now that's a vast simplification, but again, we're just talking about popular operating systems. So, Linux, Chrome, Mac OS, all these things come from Unix. Now, let's talk about Linux and Unix and all that stuff in a little bit more detail so that you understand what exactly Linux is, why it exists. So this is a diagram
my
from
God.
Wikipedia, that shows the history going back to 1969, early Unix versions, and how it spawned all the other operating systems that are connected to it. Now what you'll see is that there are three colors. Red is closed source, or pink, and that means the code is completely closed off. You can't edit it, you can't view it, you're not allowed to even try to do it. Then we have open source, which you may be familiar with that term. The code is openly viewable. You can change it, make your own versions, try things out. And then there's in yellow this mixed/shared source type of operating systems. So what you'll see here is that early on, Unix and a lot of other operating systems in the early days were mixed or shared source. But then there was a plethora of closed source operating systems that were very walled off, and you were not allowed to do anything with that code. You were not allowed to view, edit, tweak, and so on. And that led to the rise of something called the free software movement. Free in this context does not mean no money, free beer. It instead means free in the context of freedom, free speech. So this software movement was all about the idea that you should be able to collaborate. You should be able to edit code, view source code, run, copy, distribute, study, change, and improve software. It should not be walled off. And the leader of this movement was this guy named Richard Stallman. So he began work on something that ended up being called GNU. That was his own free software alternative to Unix. So he wanted to make a full operating system that had everything that normally came with Unix, but it was going to be completely free. Again, free meaning you could tweak it and edit it, do whatever you want to it, and see the source code. Now that's a huge undertaking, creating an operating system. And at the same time, this other developer named Linus Torvalds was completely free. Again, free meaning you could tweak it and edit it, do whatever you want to it, and see the source code. Now that's a huge undertaking, creating an operating system. And at the same time, this other developer named Linus Torvalds was working on something called a kernel. And we'll talk about what that is in a moment. But this kernel he was working on, he called it Linux. And the kernel is a very complicated and critical part of an operating system. It is the thing that basically sits between the hardware and the software, and it facilitates the interactions between different pieces of software and then the physical hardware of the computer. So what happened is that Richard Stallman was working on the GNU project, trying to build a full operating system. Well, he didn't have a kernel. But at the same time, Linus Torvalds was working on a kernel, and Torvalds ended up merging his kernel with the existing GNU components from Richard Stallman to create this whole operating system. Just a quick note, so I don't get any negative comments here. There is a bit of controversy over the name of the resulting operating system. A lot of people, most people have heard of Linux. Fewer people have heard of GNU. The term Linux, often people use it to refer to the entire resulting system.
Linux is not Unix. Linux is not Unix. That's what it stands for.
When in reality, the Linux kernel was just one piece that was added on to some existing components. But what matters for us here, if we go way back to this slide over here, is that what we see is a bunch of closed source, Solaris operating systems all over here. And then this thing called Linux pops up right there in 1991 in green. It's open source. Now there's not a direct line, as you can see, going back to any of these what are called true Unix operating systems. And the reason for that is
today the name Unix is a trademark of a global consortium called the Open Group.
They own the trademark for Unix. In order for you to call your operating system Unix, if you make an OS, you want it to be certified. You have to pay a lot of money. You have to go through a bunch of testing. You have to comply with a bunch of regulations and standards, and it's a complicated process, and there's money involved. It's not very free software. So we have another term. There's true Unix. You've been certified as a true Unix operating system, and then we have Unix-like operating systems, which are compatible with the Unix standards. They implement things correctly, but they haven't been certified as actually true Unix. And this is often because of financial considerations or ethical objections to the existence of the idea of true Unix. And this is often because of financial considerations or ethical objections to the existence of the idea of true Unix. So what we see on this slide here is Linux enters the picture. It's not considered true Unix, or rather it's considered Unix-like system. Remember that Linux enters the picture is not considered true Unix, but rather it's considered Unix-like. Remember that Linux itself is just a kernel, which is very, very important. It's, again, that piece of the operating system that connects the hardware
itself
to the
is not a full-blown operating system.
Really, it's the kernel.
You have to add packages.
Talk about things like Ubuntu. What Ubuntu is a Linux distribution. It is one of many, many distributions out there. There's nearly 1,000 last time I checked. You may have heard of Fedora, Slackware, Ubuntu, that's what I'll be using. And what each distribution is, it's the Linux kernel. It's some GNU tools, documentation, a package manager, a desktop environment, a window management system, a whole bunch of other things combined together.
Fedora, Ubuntu, Debian, and Slackware. Bro, what about Red Hat Linux Enterprise, RHEL, the most famous
management system, a whole bunch of other things combined together to form a full operating system. So to recap all of that, there are tons and tons of operating systems on this chart. You can see some are open source, some are closed source, some are mixed source. Some of them are considered true Unix. They've been certified by this foundation or this consortium to be true Unix. But then over here we have Linux. Linux is fully open source, and whether you call it Linux or Linux GNU or GNU Linux, it is a Unix-like operating system that conforms to all these standards these operating systems do. We can use the same commands. Things are structured the same way. There are subtle differences, but it doesn't really matter. Everything on this chart here, they're all part of this greater Unix family or Unix-inspired family. Now we have one last piece of terminology and history and all that stuff to get out of the way before we move on to actually running commands. We need to talk about the term shell. So you may have heard of this before, and if you're on Windows, you may have heard of PowerShell, or you may have heard
It's
of
the shell
Bash or
outer
C
layer.
shell, or you maybe never have heard of them. But there's this concept of something called a shell. What the shell is a very, very important piece of software that is going to expose the operating system itself to human users or to other programs. So it is the thing that takes our commands and hands them over to the operating system to actually perform. And the term shell comes from the fact that it's the outer layer around the operating system, like the shell around an oyster. So there's this other term, terminal. Way back in the day,
Yes.
a terminal used to be an actual piece of hardware. It would have a screen, and it was a physical device with a keyboard. You'd go over and you'd enter your commands into the terminal. Today, terminal is just a piece of software. It's an application. There's many different terminal
There's a
applications.
software engineer, there's a system engineer.
It's the place we go to type our commands. When we hit enter, there's some shell that we are using in that terminal window. By default, on Ubuntu and most Linux distributions, that shell is called Bash. On Macs these days, the shell is called Z shell, ZSH. Another very popular shell is Fish. There are
What?
On Macs these days, the shell is called Z shell.
Who use
on
Bash?
Ubuntu and most Linux distributions, that shell is called Bash.
Yes.
On Macs these
Born
days, the
again shell.
shell is called Z shell, ZSH. Another very popular shell is Fish. There are many other
Fish.
shells out there, though. And again,
couple
their
much?
job is to take commands that we provide, or other applications, humans or applications provide, and then give them over to the operating system and make sense of it all. So again, I'll be using Bash. That's the default shell. It comes with Ubuntu. But if you're on a Mac, we'll talk about installation, and you'll see that, fortunately, Z shell is very, very similar, and the commands are still going to work. So it's not a big deal at all, but it's good to know that there are different shells. And then the job of that shell is to take those commands and pass them over to the operating system. And as I mentioned, Bash is the most popular shell out there, especially
Born
on
again
Linux-based
shell.
systems. It is the most common
Born
default shell.
again
And
shell,
the
a
name, if
puny
you're wondering,
reference
comes
to
from
Stephen
again
Bourne.
shell, and it really doesn't matter.
Stephen
but it's
Bourne,
just
the
reference to this
creator
guy,
of
Stephen
Bash
Bourne, who
director,
created a
ancestral
different shell called
shell.
SH, a direct
Bash runs
ancestor
on
of
pretty
Bash.
much
So there's SH
every
and then
version of
Born again,
Unix
SH.
and Unix-like
And again,
systems.
Bash will run on pretty much every version of Unix or Unix-like systems. So it does run on Macs. It runs on any Linux distribution, any of the Unix operating systems that you can see on that massive chart. Next up, let's talk about setup and installing things if needed so that you can run these commands. So right now we're looking at a Linux distribution. This is Ubuntu. This is the Linux distribution I'll be using throughout the course. If you already have Linux, if you have some version of it, some distribution, just use that. It's going to be very, very similar. All that you need to know is there's a built-in terminal application. I just search for terminal.
Wow, I just built the most amazing workflow on Monday.
Shut up!
Build your own workflow? Why?
Shut up.
I'm going to be running my commands in here.
He's using Ubuntu. I don't like Ubuntu. I like Red Hat. I've been using Red Hat for a while.
cd cat the command tree command stand wc what is who and where is man info. So
Let's
this
go,
thing-
let's go,
so
let's
the
go.
first
Don't waste
one I'm
time.
going to see
Thank
is
you.
that date command.
Date
So
command.
basically
You put
command is
date
very
and you get the date. You put date in your system, a command, and you will get the date.
most useful to check the date, and as well as if you would like to
Calendar.
use any backup methods. For example, say
Okay.
I want to copy some of the files from
Copy.
one location to another location, or I wanted to take some file as a backup. So, example, I wanted to copy some of the password file from somewhere else to somewhere else. /etc/password file.
Password
so I want
file.
to copy to the
Copy from the source destination to the source. What? From the destination to the wherever you want it. Temp, and you could make a new name.
EMP, but I would
Password
like to keep this
one.
with the date
Okay,
command.
password with the
on.
date.
So just I would like to
Oh, nice.
say that it should be in year format with month and date. So what happens while copying the file? So it will copy the file with the current date, today's year, date, and month.
That's nice.
So year, month, date. So whenever you go to the /tmp here, sorry, then you can see that this is the file you have just copied from this location to this location with the date ended with that. So that way, date can also be used in more ways. So that would be more useful in daily activities. So that's way you can just use it. Date. Example, if you would like to print the previous date, something like that. Hyphen date equal to hyphen. You can also provide -1 day. So it will print the previous date, like so, which was February 27, which is February 28 today, something like that. So
2 plus
you can also
1.
print 1 year ago, tomorrow.
2
like
plus
this.
1, bro.
For example, tomorrow.
Just do +1.
You can also enter something like this. You can also
Plus
enter
1.
something like last year, like
Shit.
year ago, something like this.
Press +1 day.
2 years ago, something like this. 1 year ago, 2 years ago, something like this. So it will print all of this. So this will be very, very useful. Example, if you like to grab the previous dated folders or files, something like that. So you can also use this date formats and get this fetched on the script somewhere else. You can also use that. So one more thing is that calendar. So calendar is the command calendar, or if you want to enter a particular month, date also, you can do that, something like this. Okay, so this way the calendar is very, very useful to see the dates whenever you would like to see that. So no need to go back and click on somewhere else and see what is the calendar or what is date or something like that. So even you can use this calendar over here to particular month or date or year that you can find out the dates. Maybe this can also be printed in that what is the date format. So clear is the command. So you can just use this to clear the command like very easy. So the remote directory, which is different directory from your present working directory, also you can list. So you can also use ls command to list out the files in the current directory, or you can also list out the remote directory, which is different directory from your present working directory, also you can list. So ls space the directory name and you can list out those files. So here ls has a many options to get this data, like ls-ldr. so you can just long list with the time on a recursive base. You can also see that what is the file and what is its permissions and what is its size of it and when it was what is the size of it and when it was created, all of these details. So it also have the custom formats, like if you would like to see this date and time format in a different customized format, you can also do that. Okay, so that has a feature to get the information of listing the files and directories. So if you want to list out example directories and identify the file, something like this, so you can also do. So here it is based out of the file type. You can identify that this way directory, something like this. So this is the directory. So the next one is pwd command. So pwd is
to see your present working directory.
Present working directory. So example, so whenever you are changing your directory from one directory to another directory, so to ensure that you are in a current directory where you are currently working. So example, you would like to work on /warlog directory here.
Watch this. PWD.
So
he's in warlog.
Myself whether I'm in a current directory to execute the command.
CD to change directory. So before he was in PWD, he was in root. It showed you present working directory. It shows you he's in root /root. Then he went to change directory. CD means change directory. Change directory, you have to put the / means like for folder, etc. War log. Folder war into log.
Location to another location or something like that. So that way you can just always verify.
Then you do PWD and it shows you present working directory is war log.
Location to temporary location or temporary location to original location. So be careful. So sometimes if you mismatch your
220.
directory,
We're gonna take a break in 5 minutes.
Old files with the new files. So that
5-minute break
on production systems. So the configuration may go wrong.
I'm waiting for us.
So that way, always be sure that, and before that, anything you're doing, so just verify the PWD through the present working directory condition. Then copy or paste, move in from which IP address.
Who command?
Who is the command basically which gives the information like who is logged in from
who's
which
logged
IP
in,
address, which terminal is used, all of these details.
Like who's using this?
W also
right? Who?
Similar details, but which is
W
extended.
similar with extended.
It was logged in and when it's logged out, what is the duration of it?
Yeah.
And it also includes how many current users are logged in and what is the current load average on this system. So that's the different formats. So you can use W to estimate that whether the user when was logged in and what is this TTI in the sense terminal is used.
222.
From which terminal to which terminal is switched from.
I think that's what happened.
All of these details you can just find out using this W command. Okay. So and one more thing is that uptime. So uptime is a very useful command. Whether is that what is the uptime of that particular server. Example, it was rebooted sometime. Then you can verify that whether the server is rebooted or not. You can just use uptime to verify that the server has been rebooted or not. Okay, and how many users are logged in, what is the load average of it and current time stamp of the server. So that is the uptime command. So touch is the command, so which is used basically for creating the empty files. Example like test. I would like to create a test file over here. You can see that this test file has been created with empty. So you can just cat it. So there is no content in that particular file. So the basically cat is used to see the content of the file. Okay, so the touch is used basically to create the empty files. So to get current time stamp of the
uptime gives you the uptime of the server.
Use uptime to verify that the server has been rebooted or not. Okay, and how many users are
the
logged in.
Server has been rebooted or not, how many users logged in, load average.
So that is the uptime. So
who W uptime touch to create folder.
For creating the empty files.
Files, empty files.
Test. I would like to create a test file over here. You can see that this test file has been created with empty. So you can just cat it. So there is no content in that particular file. So the basically cat is used to see the content of the file. Okay, so the touch is used basically to create the empty files. So rm command is used to
Remove
delete the files and directories. Example, if you'd like to delete the file just created, then you can use the rm
Remove
command.
test file.
It says that removing the regular file is empty, you'd like to delete or not.
Yes.
If you say yes,
Why?
then it will delete it. So example, if you'd like to create a number of more files.
Yes.
So I just
Touch.
create some of the files over here.
Test 1
Like
to 1 to 10.
Okay.
Okay.
Files. Then you can see that text files has been
1 to
created.
10 file
If
has
you'd
been
like to
created.
delete
Test 1, test 2, test 3, test 4, test 5. You just created 1 to 10 files in 1 second.
those files. Example,
Remove test 1 to 10.
Then it will ask each and
Test
every file
all.
saying that do you want to remove, do you want to remove. So if you have multiple files, then keep on saying yes. That is a very time-taking process and much irritating process for us. So instead of that, so if you say -f, do not ask anything, forcefully delete the
Remove
file.
hyphen forcefully delete.
So then you delete the.
I'm going to take a break, guys.
When you are deleting this,
We'll continue again.
options.
5 minutes, 10 minutes, 20
If
minutes.
you like to delete any directory, example,
Make directory
I just create
test
a
file.
with
You just made a
here.
directory,
I like to create
making directory with test file. Remove RF.
delete it, then with the option,
Remove
the
hyphen
option
F,
also, you
test
can
file.
delete. But always whenever you're deleting the
D.
directory, you just use the
R.
option.
Okay,
it's
R,
a
sorry.
recursive option to delete
RF,
the
recursively,
directory
yeah.
in a R. So mkdir is basically used to create the files.
mkdir.
mkdir and with the path where you would like to create it.
225.
Directory, you have to
We're going to
specify
stop
the,
here somewhere.
path to create the directory. So you can say that
Make directory test
folder directory 1.
Directory
So I just
1.
created 2 directories.
You just
So if
create
you'd like to
directory
create,
1 and test
parent
folder.
directories. So example, directory under
Parent directory,
so
directory
you can
in a
also do
directory, you can do
that.
make directory.
You have to
Hyphen
use
P is for
test
parent.
1,
Test 1
test 2,
inside test
test
2,
3,
inside test 3.
and is the directory.
Meaning
So just
test
create
3
it.
is
And if
inside,
want to
you
go
know.
to those directories,
So
test
if you
1,
do CD, you will have to do, it's only test 1. You don't see test 2, you don't see test 3, you don't see Ravi. When you go into test 1, CD test 1, then you do ls to list what is inside there. You can do that like that too. Or you can just give the whole absolute path.
change it to the those directory, something like this. So that way you can use the mkdir command to create the directory. So mkdir in the sense make directory.
Make
so
directory.
the
mkdir
is changing the directory from
make directory. CD
So
is change
mkdir
directory.
Make directory.
226.
So the CD is changing the directory from one directory to another location.
We'll pause here. 226.